Introduction to Circuits. Chapter 18 in our book is all about circuits. So, the first thing we need to learn in circuits is, number one, what defines them, and number two, how to draw them properly. So let's look at a couple rules that you have to have in order for something to be a circuit. Rule 1, you must have a power source of some nature. Your book may call this an EMF, an electromotor force, because an electromotor force pushes the electrons through the circuit. Examples could be your AC power outlet in the wall, could be a battery, could be a capacitor. These are all power sources. They supply voltage. Number 2, there must be some form of resistance. If there's no resistance, you really don't have a circuit. And a resistance can be something as simple as a light bulb. It could be a light bulb, it could be an LED, it could be a toaster. You know, it's just whatever is utilizing the electricity. And I must correct myself here. Power source. And when I say power source, I'm using the very common way of speaking, not P power. Okay, sorry. And number 3, there must be a complete path for your electrons to follow. If you don't have a complete path, it doesn't matter how hard you push on the electrons, they're not going to go anywhere. And the bird. It's okay. So circuit components, matching. These are our drawing things, and we need to match them up. This is a battery. You might recognize it from the negative and positive. A resistor here represents resistance with the curly Q, and a light bulb, you'll notice, has a resistor inside of it. And then a switch, this would be a closed switch, this would be an open switch. So both of those switch and wire is just a straight line. Nice and easy. Now, let's make a comparison between an electric circuit and a municipal water supply. And I know this isn't a perfect comparison, but it's helpful, I think. The pump house, that's what pushes that supplies the water push, right? So your battery is equivalent to the pump house. The battery supplies pressure from point to point, the voltage. The pipe itself we can call the wire. Current would be the rate of flow through the pipes, and the resistance is changes in the piping. Now, you know, if you think about it, when there's the big water pipe that goes down probably underneath your street or at least off to the side of your street in your neighborhood, and when the water comes to your home, it comes into a smaller pipe. And, you know, even within your home, it goes from smaller pipes to smaller pipes, even in, you know, to your sink, to your shower and whatnot. So these are all changes in the pipe that is forms of resistance. So your sink would be a form of resistance for the water flow, just as different changes in your wire are forms of resistance in a circuit, like a light bulb or something like that. All right, time to make a drawing. We got some components here. I've got a battery, a switch, and a resistor. I'm just going to kind of link those up and grab my pen here and draw from here to there, and from there to there. Voila! I made a circuit. It's not really all that complicated. You just have to have a complete path, a power source, and resistance. The switch is nice, but is not by rule necessary. Try another one. Got a switch. Okay, we're just going to draw from there. Hook that up to the light bulb to the battery, add some wire here. Notice wire doesn't have to take any particular shape at all. It just has to connect. So we have a whole one constant loop there, making a circuit out of it. So question, yes or no, are these working? This one, you've got power source, complete loop, and a light bulb. Now, one little note, see this little gap right there? That is just an imperfect drawing. That is not a, oh, I'm trying to trick you kind of gap on your drawing. So if I grab the eraser here, grab the eraser and go, pow. Now, that, definitely not a working circuit, but that's not the case. That's not what we're looking at here. So this one, give me the pen, is a yes, that is working. This one here, yes, that is working. You got power source, resistance, and a loop. This one, though, not a working circuit. If we close it, is it good to go? Yeah, it's good to go if we close it, but it's not closed at this time. If we move this here light bulb, haha, surprise. Homework, 633, 1 through 5. And on these questions, don't overthink them. They're not very deep cerebral questions. All right? Good luck.